Hello everyone, I'm going to talk about the study of structural and electronic properties of zirconium-2 carbon. This study focuses on the electronic properties of zirconium-2 carbon by very simple calculation based on the DFT. The calculated lattice parameters and band structure for zirconium-2 carbon are in good agreement with previous experimental and theoretical results. These systems are energetically stable, and the band structure and density of state show that this structure have a metallic nature with the studied configuration. It's important to note that zirconium carbide is a very hard refractory ceramic material. Its crystalline structure is rock salt type. The application of this compound is wide, since medical to engineering fields. Zirconium-2 carbon structure is an M2X type xen that has been obtained by the M2AX type max files. xen contains scandium, titanium, vanadium, and zirconium have been reported to be promising for energy storage applications. All calculations were carried using system code based in DFT scheme. The crystallographic 111 was employed. The exchange and correlation effects were simulated by the GGA and LDA approximation with the PPA and CA parameterization respectively. A 5x5 supercell was used. The cutoff energy was 460 Rydberg, and the integration over the Brillouin was simply using a 5x5x1 grid on the Monk-Sharp back scheme. Three different magnetic configurations were evaluated: non-magnetic, ferromagnetic, and antiferromagnetic. We can see the structural properties at the left, top, and the right side view of the zircon-2 carbon system. The table 1 shows for the different configured magnetic the lattice parameter, the carbon-zirconium distance, as well as the internal angles and the vehicle angles. The results of the lattice parameter are compared with experimental and theoretical data. The energetic stability was obtained by the cohesive energy. The figure shows that the non-magnetic behavior is the most stable. The band structure, the total and partial densities indicate that for all behaviors the system is metallic. The charge density difference shows that the carbon attracts the charge donated by the zirconium atoms. As conclusions, the lattice parameters for zirconium-2 carbon is close to experimental and theoretical results. Zirconium-2 carbon have a high buckle angle. The electronic band structure shows a metallic nature. Partial density of states shows that zirconium atoms contribute more states in the conduction band, while carbon atoms in the valence band. Carbon atoms gain share while zirconium atoms donated. The most stable systems are the non-magnetic configuration. The electronic properties of zirconium-2 carbon are very similar to graphene. These carbides could be useful materials for energy storage. These carbides can be studied as anions for electrolytes in lithium, sodium, and potassium batteries, as useful compounds in catalysis such as carbon dioxide or methane. This work was partially supported by the multidisciplinary projects. In addition, Muñoz and Antonio want to acknowledge support from CONACYT and BEFI IPN. Rosas and Pilo acknowledge the postdoctoral scholarship granted by the GAPA. The authors acknowledge the computational facilities from the Centro de Supercómputo de GETIC UNAM. These are all references of this work. Thanks for your attention.